If you're a camera, a 3D camera, and you're looking at her and she's pointing in that direction, the question is, what do you call X, what do you call Y, and what do you call Z?
I would want to take all the knowledge that I've learned throughout this camp using Quorum and maybe develop my own game maybe later down the line.
I really want to teach others. That's sort of what I like to do, and with Quorum I can do that much easier.
Quorum, an accessible programming language.
Is we're now going to say box.
Technology jobs are in demand, and an understanding of computing and coding are important for anyone pursuing these opportunities. But learning programming languages can be difficult for any new student, including some students with disabilities. That's why Quorum was created.
My name is Andreas Stefik. I'm an assistant professor of computer science at the University of Nevada, Las Vegas. Other fun little things. I invented the Quorum programming language at first, and then my wife and I actually created several versions of it together. It was originally designed to try to help blind or visually impaired students learn to program more easily. The reason was because at the time, a lot of computer science was moving toward very visual content, and that in general makes a lot of sense. However, not if you're blind.
I'm Richard Ladner, professor in computer science and engineering at the University of Washington. So you really need sort of similar code to what you have there already. Children who are blind, who can't see, can actually program in Quorum and make things that talk or have sound or have music, so they're not always so visual. If you look at almost all the tools that are out there for children, they're all super visual. And this one is visual and auditory. So that makes it much better for everybody.
I'm Lauren Milne. I'm a graduate student at University of Washington in computer science. I work with Richard Ladner, and I do a lot of research in programming languages, specifically for blind students. It has full support for screen readers and like Braille displays. And it has a lot of features. It's like very easy to incorporate audio and programs and a lot of things you can play around with in audio. So it means that you can make really accessible, you can quickly and easily make accessible games or whatever you'd like using Quorum.
Quorum's features are universally designed, making it an easier language to learn in general.
One of the reasons why Quorum is easier in some cases for people to learn and grasp is because the language is simpler, which impacts people with learning disabilities. For example, if I was to tell the computer to do something over and over again, in a language like Java, I would say for left paren int I equals 0 semicolon I less than 10 semicolon I plus plus right paren left brace, which obviously means that we should do something 10 times. In Quorum, I say repeat 10 times.
I find personally reading Quorum programs a lot easier than reading C programs or Java programs, that I can understand them more easily. And so I feel like there's some major advantages from the get-go, just that simple elegance. Most languages, after every single line, you have to put a semicolon. Why you have to put a semicolon? It seems to be just tradition. It doesn't need to be there. And Quorum has no semicolons.
I hypothesize it could be really good for certain students with learning disabilities. That Quorum doesn't use braces, it uses sort of indentation, and it uses the word keywords instead to indicate the end of loops.
I want you to type the word model, and then I want you to type the word box. Now, there's a red underline here because we haven't added the use statement.
Over the years, Quorum has gained popularity.
I'm Dominic, and I'm really into computers and really enjoy using Quorum and have used other computer programs before like C++ and Java. One of the things that stands out to me in Quorum is the punctuation, and it's really easy because you don't have to add in all the semicolons and all the annoying hash hashtags and @ symbols and everything. You just use words basically, which is way easier than using all those confusing symbols. And I think that makes it easier for me to program in Quorum than other languages.
Hi, I'm Alyssa. What makes Quorum easier is the way they programmed for us to write the code. So we don't have to add semicolons and brackets and parentheses and all this stuff. They made it easier. You can just type in a word output, let's say for example, and then you can write in quotes whatever you want the computer to say. And that's what makes it a lot more unique than other programming languages like Java.
I'm Mary. You can do a lot more things in Quorum with less lines of code than in some other things that I've used before.
Quorum is evidence-based, using the results of scientific experiments to determine how to make the language easier to use.
Quorum provides two primary benefits. One is everything is free, and then number two, at the end of the day, all of the materials that we use and that we give to people are vetted both by teachers and students and are vetted in experiments through the scientific method.
The result is a programming language that is creating a more inviting environment for computing students.
So a lot of people, I've seen this in intro classes that I've taught, they come in and they get really intimidated the first, when they start programming, and there's all sorts of bugs, and it can be very frustrating. People drop out, and very often the only people who stick around are people who come into like a college course with previous programming experience. Anything that lowers that initial entry, I think, is going to bring a lot more people, a lot more diversity because of that.
To learn more about Quorum and how you can encourage and support students with disabilities in computing courses, visit uw.edu/accesscomputing/accesscs4all or quorumlanguage.com. Access Computing and Access CS for All are supported by National Science Foundation grant numbers CNS-1042260, CNS-1539179, CNS-1440843, and CNS-1440878. Any opinions, findings, and conclusions or recommendations expressed in this video are those of the authors and do not necessarily reflect the views of the National Science Foundation. Copyright 2017, University of Washington. Permission is granted to copy these materials for educational, non-commercial purposes, provided the source is acknowledged.